So we've been talking about equilibria and how we can understand relative concentrations by looking at the equilibrium constant. So the ones we've been looking at so far have been gases, both reactants and products. Here we have a solid reactant and a solid product and a product in the gas state. So the equilibrium constant uses the concentrations of the reactants and products. The concentration of a solid doesn't change. You cut the substance in half, its concentration is the same, because the concentration would be moles per liter or moles per gram, and it's not going to change. It's not like a solution or a gas where you can change how concentrated the substance is. A solid is either there or it isn't. So we omit any solids from the equilibrium constant because their concentrations do not change. So in this chemical reaction, because the calcium carbonate concentration doesn't change and the calcium oxide doesn't change, the only thing that we have a concentration for is the CO2. So the equilibrium constant for this reaction is just the concentration of the CO2. So let's write an equilibrium expression for this chemical reaction. So we're looking at KEQ. Oh, that's not the marker I want. This is it. KEQ. The equilibrium constant will be the concentration of the products, the molarity, divided by the concentrations of the reactants, each of those raised to the power of the exponent. So let's look at our products here. Water as a liquid. Does the concentration of water change? No, water is water. It's a pure substance, right? So liquids also are not included. Solids and liquids are not included in the concentrations. The concentration, the molarity of water is always pretty much the same, 55 moles per liter. So we're going to leave this one out, and we're going to have this concentration. So we've got the concentration of the chlorine gas, and the coefficient there is 2, so this is squared. And then we divide by the reactant concentrations. Here we've got both gases, so those can change in concentration. So we've got HCl, and what should be the exponent there? 4. And the O2 would have an exponent of what?
1.
Of 1. So that's the equilibrium expression for that chemical reaction. Any questions? So we leave out concentrations of solids and liquids because they don't change.